Okay, so good evening, everyone, and welcome to another math class. This evening, we are looking at relations and functions. So you're going to start with what is a relation. We're not going to stay too long on this. Anybody remember what is a relation? Anybody remembers? So a relation is a set of ordered pairs, which is defined, or it's obeying some rule. So a relation is a set of ordered pairs. What we're going to do now is understand what I mean by ordered pair. All right. And that's plural, not singular. So let's just add the S to this. So it's ordered pairs, which is defined by a rule or a formula. So we'll need to understand what I mean by defined by. All right, so this ordered pair is usually looked at as an X and Y coordinate. Yeah, X and Y coordinate, this is what we call your ordered pair. So when I'm talking about an ordered pair, I'm talking about I'm talking about your coordinates. All right. So let
Good
me,
afternoon, so sorry for coming late.
good evening. Good to have you. So when we talk about ordered pair, we are talking about your X and Y coordinates. So I'm looking at that is, all right, I want people to pay close attention, all right, to what I am doing. So this is a pair. Am I correct to say that the X and Y, they are a pair of something? They are
Yes,
two
sir.
things, right? Good. So, um, good. So we understand when we say ordered pair, what we mean. Now, the defined by, what we mean by that? Defined by. What do we mean by that? We can use a formula such as Um, y equals to 3x minus 2. So I want you for me to if I have a set of values such as let me put my values. Let's say I have my values such uh so we have x values and we have our y values, right? It's producing a pair. So let's start with -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Right? So you're gonna add these. So we're starting with -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. Right. So we have our x values, right? But we have a formula. We have a formula. What you need to do is use the formula to give me the values of y. So I'm just going to call people and ask them for the values. Oh, okay. Here what you're going to do. You're going to put the value of y when x is -4 in the chat, everybody. So how many persons we have here? There are 14 persons here. When x is -4, what is y? So give me the value of y. Remember, we are using so we're using this formula. So when x is -4, right? So as you put here for answers, I'm just going to tell you. All right. Correct, Matthias. Correct. All right, good to see you, Tashira. I saw you trying to get in several times. If you can't, you could always use another device to get in. Udaya, correct. Shalome, no, you made a mistake. Mikhail, correct. Antonio, you made a mistake, Antonio. Sienna, correct. Jamelia, correct. Anybody else? Kylan, no. It's just a substitution, Kylan. Garcia, no. Sahai. All right, Sahai went ahead and she did all, which is good. So let me just quickly um Antonio, no. Tashira, yes. All right, so this is a formula. We can't stay on this, people. So I'm just going to quickly tell you where you made a mistake. So I'm just going to move the formula out just a bit. Right, so when I substitute x, it will now be 3 times, but x would be -4. -2. -4 times 3 is -12 minus 2. So y is equal to -14. Everybody okay with that? Yes, sir. So when I substitute 3, it will be -3 times 3, which is -9 minus 2 will give me 11, -11. -2 times 3 is -6 minus 2 is -8. If I substitute this and put -1 times 3, -3 minus 2 is -5. Um, if I 0 times 3 is 0. 0 minus 2. 1 times 3 is 3. 3 minus 2. 2, 3 twos are 6. 6 minus 2. Where are we? All right, people are coming in a little late. I'm not sure why. So I have to stop to try to allow them in. All right, so you have -3 times 3 is 9. 9 minus 2 7. 4 threes are 12 minus 2, which is 10. And 5 threes are 15. 15 minus 2 is 13. Anybody lost? No, sir.
No, sir.
All right. So what kind of graph would I have sketched? Anybody? Using this formula, y equals to 3x minus 2. What type of graph would I have sketched? Jamelia. What type of graph, Jamelia, would this be? Yes, Mikkel.
Straight line graph.
It's a straight line graph. All right, Jamelia, you understand why? Why would it be a straight line,
Yeah.
Jamelia?
So I heard you say my name, but then it cut off for a second.
Because we're using y equals to mx plus c. Jamelia, I had asked what type of graph would the formula, this formula, y equals to 3x minus 2, what type of graph would be drawn? And Mikkel said it's a straight line. All right, so that was the question I was asking.
Okay, sir.
Yeah. All right, Sienna. So it's a straight line. All right, so why did we do all this, people? We did this to show that the relation, so the first relation is -4 and -14. Everybody agree with that? That's my first relation. Everybody agree with that?
Yes, sir.
My second relation would be -3 and -11. So would you all say that these pair of numbers are ordered? Somebody answer me. Would you say that these numbers, pair of numbers, are ordered?
Yes, sir.
All right, thank you, Antonio. What do you think, Matthias? Are the numbers ordered?
Yeah, I would say that.
And
Yeah.
why would you say it's ordered?
Because it follows a continuous pattern.
Because it is following a equation,
Pattern.
a formula, right? So that formula or it gives it a pattern. So it's ordered. And this is called a relation, right? Now, everybody's okay with this? I'm moving on to functions. Now, but before I move on to functions, there are some words that you would have done before that I just want to share with you now. All right. So listen up. Moving pretty fast. Okay, so we had X values, all right? The set of X values that we just had, all right? They are all defined as numbers in the, anybody want to tell me all these numbers, the set of X values? Let me go back. Starting from -4 to 5. So I'm going to write them -4, -3, -2, -1, 0, 1, 2, 3, 4 theories and 5. What do we call this set of X values when we're dealing with a relation or a function? But we haven't gotten to the function part yet. We're just still talking about the relation. Anybody want to say? What do we call this set of X values? Come on, people. A D word.
Domain.
Domain. Thank you, Sahai. So this is the domain. All right, so the domain, I do have to give a note on this, people. The domain represents the set of X values. All right, the domain represents the set of X values. Now, we got our Y values as well. We got our Y values as well. All right, so this is a little, all right, let me do better than that. So what was 4 linked to? What was the number 4 was linked to? Somebody just call them out quickly. 4 was linked to negative 14.
Negative 14. Yeah.
Negative 3 was linked to
Negative 11.
Negative 11.
negative 2,
Negative 8.
negative 1,
Negative 5.
5.
0,
Negative 2.
1,
1. 4.
2,
7.
3, 4,
10. And 13. Yeah.
so so the set of Y values are called what? Somebody, the set of Y values are called the
Range.
range. Right, so we still have the ordered pairs. We still have ordered pairs. But they are defined by a formula. And that formula was y equals to 3x minus 2. All right, so they are defined by this formula, but it only allows them to go from left to right. Now, to go right to left, anybody knows what I have to do? All right, so we'll talk about that later. In fact, I'll tell you now. If I take the negative 14 and plug it in, would I get back x? No. To get to go back from right to left, I must find to move from range to domain. I must find the inverse. All right? So to move from right to left, to go back the other way, I must find the inverse of this formula here, which we're going to do today. All right? So let's start all over as a recap. When we started off today, we started a relation. And we said a relation is a set of ordered pair. And for this to be ordered, it must be ordered by some formula or rule. So we gave the formula y equals to 3x minus 2. So wherever we had x, we found for y. So these numbers became ordered because they obey a rule, which was this. This is a rule that they are obeying. All right? Now, we said the set of x values represent the domain, and the set of y values represents the range. So we move, the formula allows us to move from left to right, from domain to range. Now, if we want to go back from range to domain, we have to find the
Inverse.
Inverse.
The inverse. Okay, Johansi? Johansi. So to go from x to Johansi, are you there?
Yes, sir.
How do we go from domain to range? What do we do? Jedidiah, tell him. Jedidiah. All right. Now, this is so annoying. I'm ready to put you in the waiting room. When you can't answer, it means that you're not there. All right? So, to find the inverse, you move from y to x. All right, good. So now I want to use certain words. We use the term moving from 3 to 11, negative 11. We say negative 3 is mapped onto negative 11. All right? So negative 3 is mapped or connected to onto negative 11. This is how we speak in functions and relation. Or we can say 4 is mapped onto ON 10. All right, so the ordered pair is negative 3, negative 11, 4, 10. So 4 is mapped onto 10. So what word are we going to use? We're going to use mapped to describe their connection. To show this, we can use, how are they mapped? How are they mapped? We can use, we say x is mapped onto y by using 3x minus 2. So x is mapped onto 3x minus 2. All right, so the arrow means mapped onto. So just write that. The arrow means mapped onto. All right, so x, which are these values, and this would represent my domain. All right, the set of x numbers are the domain, and the set of y numbers, this represent my range. So you need to write x arrow 3x minus 2 means the arrow means mapped onto. X is mapped onto 3x minus 2. All right, that's how we read it. All right, I'll give it 2 minutes and then we start functions. All right, so let's go to functions now. So we were talking relation, and now we want to look at a function.
So I ain't finished writing it yet, sir. Thanks, sir.
You're welcome.
Yes, sir. I done it.
Okay. All right, so let's look at a function. Now, a function is a relation in which a function is a relation in which one number or element in the domain, or I shouldn't say that. A function is a relation in which each element, all right, let me just write this. Or number in the domain or x values a function is a relation in which each element or number in the domain or the X values is mapped onto one and only one element or number all right? In the range. Or Y values. Now, we need to understand what this means. So let's point out the keywords that I'm using. So it is a relation. Oops, I don't want that one. It's a relation, meaning that there's a formula. All right? It means that there's a formula. Right? So a function is a relationship or relation in which the element in the domain is mapped onto only one. Now, this is the key part. Only one. That is the key. That is the key part. Only one number in the range. So let's explain what that means quickly. In fact, I'll draw it too. So you can have range, you can have domain, and you can have range. You only can have the numbers going to one number in the range. So I can have in the domain, I could have one going to one number, right? I can have one number going to one number. Or I can have two numbers going to, so let me put it like this. How many numbers would I go to in the range? Anybody? How many numbers would I go to in the range, given the rule? How many numbers would I go to in the range? It will be
Two almost 1
only one number. Can't go to any more than that. So there's two numbers going to one. One going, so it could either be this or this. One number going to one number. We call this one-to-one mapping. Or we could have it like this. We call it many-to-one mapping. And this is what we call a function. I'm going to explain it more as we go along. So don't, all right. Somebody was trying to get in, but I do not know what just took place. All right. So this we call 1-to-1 mapping. All right, so you're not seeing that good. Use a blue color. And this is called many because it's two numbers. Many-to-one mapping. I'm not going to ask you if you understand. So take this down. We're going to do more questions as we go along. And you'll understand it better. Time. You let me know when I can move on. I'm ready. Kind of have a lot to do in a short space at it. Now I will actually come back to this. Right? Make sure that you wrote it down. You write it down so that when I come back you could come back to it, you could check your notes. Because I would define or explain it even clearer. Jedidia, are you there?
Yes, sir.
Right. So Jedidia, if you have to leave, let me know. Because when I was calling you, you weren't around. All right. So let's move on. I hope everybody's done with this. I will
You're still on
recap.
the last part.
Oh, okay. I'll recap later on. All right. All right. So we need to go. All right. So let me give an example. And this is how we're going to write a function. This is how we're going to write a function. All right. A function would be defined by, instead of using x, is mapped onto, let's say, 3x plus 1. Let's make that minus 1. Plus 2. Right, this is how we would have write a relation. X is mapped onto this. But now we're going to put it as a function of x. The function of x is mapped onto this. Now, people, let me write that. The function is mapped onto all right. Now, it also can be written, this is the same as saying, f of x, f of x is equal to 3 into x minus 1 plus 2. So I'm going to write it the function is equal to f of x is equal to 3 into x minus 1 plus 2. Okay, Matthias? So this is how we're going to write. This is how we write it, Matthias, Tyrese, Kylon, Ezekiel. F of x is equal to 3 into x minus 1 plus 2. F of x. Now, this is the same as saying y is equal to 3 into x minus 1 plus 2. Therefore, f of x is also equal to y. So let's start all over again. Initially, all right, so I know people are writing this down. Maybe 2 minutes, 10, 30 seconds. You have to take off this relation part, because this is now a function. A function is a relation that maps each element in the domain. It's mapped onto one and only one element in the range. That's a function. There's more to it and more to be explained, but as we go along, I'll explain it even better. All right? All right, so when we started off, I said if I take off this x, it will just be x is mapped onto, well, 3 open bracket x minus 1 close bracket plus 2. That is what x is mapped onto. But if we're dealing with the function, then it would be the function of x is mapped onto, so I should have put here the function of x, but that's all right. The function is mapped onto that, which is the same as saying f of x is equal to that. F of x is equal to, which is the same as saying y is equal to. That means f of x is also equal to y. Now, pay close attention, people. Don't miss me. So f of x is equal to so therefore, what is f of -4? So when x is -4, what is y? Because remember, f of x is y. So we have 3 open brackets, -4 plus -1 plus 2. Work your brackets first. -4 minus 1 is -5. So f of x or y is equal to -13. So we did the same substitution, but now we call this f of -4. All right, so the function gives us the value of y. All right, now listen carefully. Listen carefully. Now, a one-to-one mapping is defined by a straight line. So if I should draw this, my y-axis, my x-axis, if I draw a line like this is a one-to-one mapping. How do I know this? I'll explain. It means all the numbers in the, if I have a number here, let's say this is 3, goes to this point here. This maps onto, let's say, 6. So 3 is mapped 3 on the x, 6 on the y. Let's call this -1. And this, let's call this -2. So -1 is mapped onto 2. So in your domain, you have 3 in the x, -1 in the x, but in the range, which is your y, you have 6 and you have 2. This is called a one-to-one mapping. All right? It's defined by a straight line. Take that down. So this is a function. So I can write, therefore, it is a function. Because we are only mapping one and only one element in the range. All right, pay attention, people. Otherwise, you're going to lose out. So I'm just going to recap. We are saying, I showed you all how to, if you have f of x equal to something, and you want to know what is f of -4, how you had to substitute your -4 and get your value of f of x or y. Now, then I explain what a one-to-one mapping does. A one-to-one mapping is defined by a straight line, therefore it's a function. So if there's a number on the x-axis 3, it maps on the line to 6. Or if you have a number on the x-axis -1, it maps onto 2. Oh, this is wrong. This is -2. -2, -2, because here is my -2. All right, so just make that correction in your range. All right, so it's always good to recap. There's CMSC. All right. All right, so let's move on. Let's move on, people. We have half an hour. We have real things still to do. All right. I have 2 other points to make concerning this. So number 2, we have 3 points in all. A many-to-one mapping is defined by a curve. So we're going to explain how it is defined by a curve. Therefore, and I'm going to explain this part. It's also a function, but I need to show you it first. So let's say you have your y-axis and your x-axis. All right? Now, if you have a curve, a standard parabola, I don't know how people getting knocked out so much today. So here is my curve. So from here let's say from this line to this point, it's one number on the X, let's call it -4. And it goes to one number on the Y, let's call it 5. But on this point, you have, and let me just do it in red. You have one number, oops. And another one, you have two X values, but they are going to, well, I didn't draw it that well, but that arrow is supposed to come here. Let's pretend it's at this point. All right, so you have two values. Let's call this -1 and -5, -3. What am I saying? 3. That side is not negative. Let's call this 3. So this value here, let's call that -5. So now you have two numbers going to one number. So two numbers in the domain or X value. Now, people, this is really important. I've seen this come for, I'm not taking my time to do this for soup. But I saw it in your multiple choice. So domain, range. There are two numbers in your X-axis, -1. Now, if you get in trouble coming in like Tashira, I want to suggest that you just use your mommy's phone or your brother's phone or your father's phone and log in. So now we have -1 going to 5 and -3 going to 5. So you have two numbers in your domain going to one and only one number in your range. Therefore, this is a function. So, a one-to-one mapping is a function, and a many-to-one mapping is also a function. Hello, I would like you all to write this down. I want to say it again. A one-to-one mapping is a function, and a many-to-one mapping is also a function. So once it's a curve, a parabola, or a straight line, it's a function. But here is the problem, people. Here is the problem. I have one more to do. It's 3, and then we'll move on. We'll go up one level. All right, could I move on? I have one more. So one-to-one mapping is a function. Many-to-one mapping is a function. And we have one more. Just learn it. If you can't remember it, just learn it. Yeah, one more. Uno más. Can I continue? What do I say that in Spanish? Puedo. O puedo continuar. Puedo continuar. Can I continue? For those people who do in Spanish. Puedo continuar. Nobody ain't answering me, boy. Well, I ain't talking to the Venezuelans, the Venice at all. I wonder if I mute. I have to be muted because nobody ain't talking.
Let's say continue.
All right, so one more. So far, we did in part 1, 1-to-1, is a function. Many-to-one and lastly, one to many. I'm writing it one time. And when I say 1-to-1, 1-to-1 means domain to range. Many-to-one, domain to range. Now we're going to talk about one domain to many. Anybody could tell me why number 3 is not a function? It has to do with the many. Anybody could tell me what and the definition that I had given? Anybody could tell me? This would have been a $5 question if we were in person. Can anybody tell me why a one to many is not a function? Nobody, boy? You there?
Because they're not mapping.
Is that mapping what? Why it not mapping? Give me more. Give me more. Give me more.
They're not mapping because it's not defined by a curve. So
It
it's
is
the opposite
defined
of
by a
many
curve,
to.
but not a normal curve. Why a one to many, according to the definition, Ezekiel, is not a function? Go back to your formula to see what is a function. Matthias, you think you could answer that? Anybody want to answer?
I'm not sure.
You're not sure?
The domain only supposed to go to one range.
Sorry? You all heard what Udaya just said? All right, or look at ask her to say it over, because she actually said the right thing. Udaya, could just repeat that for the class, please?
The domain only supposed to go to one range.
It's supposed to go to one element in the range. That's correct, people. It must go to one element in the range, but it's going to many. So that is why it is not a function. Okay, Tyrese? Where's Jadidia? Everybody heard that?
Yes, sir.
All right. So now, Johansi, you heard that?
Yes, sir. Yes, sir.
Johansi.
Yes, sir.
All right. All right. So let's see if we can Let's see if we could properly define and explain a one-to-one mapping now. So again, I'm going to construct my graph to show you. This comes from multiple choice, and you want to get all correct in your multiple choice, right? So we're doing one-to-one mapping, one-to-many mapping. Now, for a graph like this, the graph was drawn like this. Now, this is my y-axis. This is my x-axis. All right. So, like here, this is a point on my x-axis. Let's call it -7. This is a point on the y-axis. Let's call it -2. All right. But people, if I have a value here, this would mean that it's the same number on the x-axis, but two different numbers on the y. And let me just show you that. Let me just use my arrow. So this will go here, and this will go here. Two y values, but one x value. So let's call this, let's call it 6. Let's call this -1. And let's call this point here 3. Let's just say call it 3. So now on the x value, what's my x value, anybody? In the domain? What's the x value in the graph? What's the x value? It's 3.
3, sir.
And 3 is mapped onto what? So this is the domain. And 3 is mapped onto what in the range?
6.
6 and
-2. -1.
So we have one value in the domain and two values in the range. I want to say that again. You have one value, Sienna, in the domain and two values in the range. So this is not a function because it must map to one and only one element in the range. Is that okay? Is that okay?
Yes, sir.
All right. Okay. Good. All right. So we're going along pretty okay. We have two more things to do. So look at this question. Given f of x is equal to 3x squared plus 2x minus 1. Evaluate f of 0. Everybody, there are two other, but I'm just doing it in parts. So everybody work f of 0 for me, please. Yeah, 10 seconds. Ezekiel, you're okay with what we are doing, Ezekiel? Ezekiel. Ezekiel. All right, so I did a lot of talking today. F of 0. Where's Mikhail? What is F of 0? Correct. Yodiah. Antonio, no. You made a mistake. Jamelia, yes. Come on, people. F of 0. F of 0. This is easy. This is the easy one, actually. Sienna, correct. Naomi, you're here? Naomi? Naomi, you're here?
Yes, sir.
All right. All right, so let's see what people. I'm seeing 3 answers from Garcia. Correct, Garcia. Johan Sear. No, you made a mistake. Tyrese, yes. So, people, let's quickly do this one. I didn't. Mikhail is somewhere. So we could write y equals, because we said f of x is equal to y, 3x squared plus 2x minus 1. So that's 3, and we're going to put 0. Let me write it in red so that so that's 0 squared. You always square first. You always square first. Don't forget that. I want to say that again. You always square first. 0, 2 multiplied by 0. And then we have minus 1. So 0 squared, you have to do that first. And that will give me 0. 2 times 0 is 0. 0 times 3, 0. 0 plus 0, 0. 0 minus 1, so y is minus 1. So f of 0, you must write f of 0 is equal to minus 1. All right, so next one, f of 2. F of 2, go ahead. Everybody, f of 2. F of 2. So everywhere you see 0, you're gonna wherever you see X, you're gonna put 2. Where's Sahai? All right, put your answers in the chat. Udaya, that's correct. Udaya. Garcia, that's correct. Garcia. Jedidia, that's correct. F, right, you wrote it correctly. F of 2. Matthias, correct. Where's Mikel? If you get knocked off, you have to come back in. Ezekiel, are you there? Ezekiel. Where is Kylon?
Yes, sir.
Right, so I didn't get any work from you, Ezekiel, and for a while you weren't around. And this is a new topic. F of 2, Antonio, no. Wherever you say you're going back, instead of putting 0, you're going to use remember to square first. So 2 squared is 4.
Oh, so I
Yes.
didn't square it inside, sir. I didn't
Yes, you
square it.
must, yeah, well, that's what it is. You square first. So F of 2 is 15. Last one. Last one. Last one, F of minus 1. F of minus 1. And then I'm going to take 5 minutes to do one last thing, which is composite function. So this was a crash course in functions today, right? The only thing that we did not do is inverse function. And we're going to complete that on Monday. All right. So what's your answer for F of minus 1? All right, so let me see what answers people had. Udaya. No, Udaya. Something is wrong there. Let me check over just to verify. Remember what is minus 1 squared? Negative 1 squared is what? So Udaya, check that again. Sienna. Right, you got your 15, but for Garcia, no. Johan, say the 15 is correct, but what about the next one? Tyrese, no. Shadidia, no. You all are getting 0, but you all are making a mistake. Antonio, no. Matthias, no. You all are making one mistake, one small mistake. So let me put minus -1, but this is -1 squared. Anybody could tell me what is -1 times -1? Huh?
Positive
Sir.
one.
+1. So -1 squared is 1. And 2 times -1, that will give me -2. Oh, yes, those people who had 0, that's correct. It's my fault. 3 minus 2 is 1. So that was correct. For some reason, right. So, yes, some people got 0, that's correct. Sorry. Udaya, you were correct. And the others who had given me 0. Sorry. Some people gave me 0. I can't remember. Let me see. Who were they? Kylon. Kylon, I haven't seen anything. Garcia gave me -1. Sahai, she's gone. I have Tashira, Johan Sear. We're looking at in Jedidia, I think gave me 0. Jedidia, that was correct. Sorry. Sienna, she had 0 too, so that was correct. Very good, people. I'm going to take only 5 minutes of your time to start something quickly, and we're going to finish it on Monday. Because I want to finish up this topic. So I want to look at a composite function. We're going to start it today. I'm going to continue it next class. Now, a composite function means a function within a function. So let me give an example. Let's say f of x is equal to 3x plus 1, and h of x is equal to 7x. And they ask you what is f of h of x. Let's use a common h instead of capital. Now, don't make this, so they're asking for f of h of x. Now, don't make it, now let me show you something, how to work this out. Now, if I ask you what is f of 2, you will find for f of x equals to 3x plus 1, and wherever you see x, you're going to put 2. Correct?
Yes, sir.
Right. Now, instead I'm asking for f of, so instead of putting x, I'm going to put h of x. So I'm going to write my f again. And wherever I see x, I'm going to put h of x. and h of x was equal to 7x. So my answer is, Naomi, 3 times 7x is 21x plus 1. Anybody lost? Take that down quickly. I will give you one simple question, and that ends our class for today. I will give you one simple one to do, and I will end my class for the class for today. Just hurry up with that. I'm going to give you one, and that will end the class for today. Can I move on?
Yes, sir.
All right. So last question for the day. If f of x is equal to 3x plus 1 and g of x is equal to 9 minus x, evaluate f of g of x, f of g of x. And g of f of x. There are two questions. So that's it for today. I'm just going to all right. All right. So I'm not seeing your work, but because of the lateness of the hour, I'm just going to do it myself. So f, we know what f is. F is this, so I'm going to write it. And then they ask g of x, right? So always put the first letter first. So I wrote my f, and my g of x, which is this, would be 9 minus x plus 1. So 9 threes, that's 27. And 3 by that is negative 3x plus 1. So we have to work out, so negative 3x So that will give me negative 3x plus 28. Anybody lost? So f of g of x, sometimes they put the brackets like that. Anybody lost?
No, sir.
No, sir.
All I did was substitute. Last one. G. So I'm going to start with G. And then of f of x. So f of x is this. So wherever I see x, I'm going to put battery. Finish it. I'm going to put 3x plus 1. But there's a negative sign outside, people. So that is negative. I'm multiplying everything by negative 1. So that'll be negative 3x and negative 1. So that will give me negative 3x. 9 minus 1 is negative 8. Notice the answer. So g of f of x, one is this and the other is this.